We're in the midst of a series that's on life and death of a blue planet. And last week, we looked at life and death in the Paleozoic era. And the Paleozoic era is the first of the eras in the Phanerozoic eon, which is the period of time that has life as we know it. What we looked at was the explosion of diversity that led to the Cambrian period. We looked at the greening of the earth as vegetation took over, the conquering of the earth, land by the animals, and then finally concluded with the great dying. And today, we're moving on to the Mesozoic era. Mesozoic is the middle era of the Phanerozoic eon. And like the Paleozoic era, it's divided by geologists into three periods of time. And the lowest or oldest one is the Triassic, middle one, Jurassic, and the youngest one is the Cretaceous, which is always shown by geologists with the symbol K, which is German. During the Paleozoic, the continents were really on the move, and they converged through the Paleozoic into one supercontinent, Pangaea. And this allowed life to really spread over all of the land masses unimpeded by the seas. But during the Mesozoic, we have just the opposite. The continent, the Pangaea, the supercontinent, breaks up into a series of continents, and you can recognize some of these as the continents that we know today. So our presentation today is going to start with the doorway to dinosaurs, flying reptiles, and mammals. We'll talk about don't go near the water and why. We'll talk about T-Rex, Velociraptor, and ducklings. Oh my! And a great explosion, and then silence. The Mesozoic is commonly referred to as the age of the dinosaurs, and for good reason, but it didn't really start that way. The Triassic period was a period of transition, and it was sort of the doorway to dinosaurs, flying reptiles, and to the mammals. It was really a time of biological reorganization. If you recall last week, we talked about at the end of the Paleozoic, the dominant land creatures were large reptiles, and the reptiles had two different kinds of skulls, a synapsid, which is the kind of skull the mammals have, which we have, and the diapsid, which is the skull that dinosaurs and birds, crocodiles, lizards, basically all the reptiles had, with two holes behind the eye socket. And as we went into the Permian, the last period of the Paleozoic, the synapsid reptiles dominated. And that's the same kind of skull we have today. And the big sailback lizards, the pelycosaurs, died out before the end of the Permian period, before the end of the Paleozoic, but they were replaced by therapsids, which were sort of mammal-looking in some respects, but were still really reptiles and some very strange and very large creatures at the end of the Permian. And the diapsids, with two holes in the skull, were basically small lizards at that time. Then came the Great Dying. And the Great Dying was a huge impact on the synapsid reptiles. There was one survivor, Listosaurus, which ended up being all over the earth at the time. Its distribution was really broad, and it managed to live through the crisis that killed off so many things at the end of the Permian. It was one of the very few, though, that made it across. And so as we go into the Triassic, which is a period shown here in sort of the rusty color, the dominant animals are now the diapsids with two holes in the skull. So they have changed dramatically, and the group that is the ruling group are the ancestors of the crocodiles, which are called pseudosuchians. And they spawn off before the end of the Triassic, the dinosaurs and the pterosaurs, the flying reptiles. The group is called by scientists that spawned off Avemetatarsalia. It took me several weeks to be able to learn how to pronounce that, and I hopefully won't have to do it again. But that is a group that paleontologists use to identify the group that includes the birds, the dinosaurs, and the pterosaurs, but not the crocodiles or lizards. The Triassic was really the reign of these crocodilian ancestors, the pseudosuchians. They were huge, and they essentially were most of the places on the earth, I think. And the reason for this was, if you recall, the end of the Permian was an extremely warm period of time. In fact, that's probably what killed off so many of the land and marine species. And that those high temperatures persisted into the Triassic. So it stayed warm, really warm, for basically most of the Triassic. And that warm climate suits pseudosuchians and crocodiles very well. So they basically took advantage of this climatic change and ruled the earth. And they were big, and some of them were really pretty strange, and some of them were really, really strange, like Canistropheus, which was about 20 feet long and had a huge neck. And what I want you to note particularly are the hips, how the legs splay out from the side, because this is a characteristic of the reptiles and pseudosuchians, where the hips allow the legs to come out to the sides as a sprawling posture, as compared to the dinosaurs and the mammals, which have the bones under the hips and allow for them to be erect. And you can see that in these skeletons. The upper one is a pseudosuchian hip, and you can see how the leg bone joins the hip from the side, whereas the dinosaur hip, the leg bone joins the hip from directly beneath. And that's a big distinction between the pseudosuchians and the dinosaurs. So we have the great dying, we have the pseudosuchians sort of taking over the world, but we do have dinosaurs and pterosaurs, and before the end, some mammals. And the oldest dinosaur-like footprints come from very close to the beginning of the Triassic. They're quite early, and these footprints, by the position of successive footsteps, indicates that the animal that had them was probably something like this. This is a guess of what it might have looked like, but this is really a very old ancestor of the dinosaurs, if that's interpreted correctly. The oldest dinosaur in Africa is a Mesosaurus, and it shows up in the Triassic. It is shown here covered with down. And this is increasingly shown by artists with a down coating. And we'll talk more about this later as to how important this could be. But by the end of the Triassic, we had some real dinosaurs, small ones like Coelophysis, bigger ones like Herreracysis, which looks like a primitive theropod, which we'll talk more about later. And by the end of the Triassic, we were seeing some of the ancestors of the large sauropods, the great animals with the long necks and the big bodies. So basically, the Triassic set the stage for the dinosaurs of the Jurassic and Cretaceous periods. It also set the stage for something else. Schleiermacher covered a substantial amount of the Triassic, and it's thought that early on it spawned off the earliest pterosaurs that probably were gliders, but by the end of the Triassic, they had learned to fly, they'd taken to the air, and the pterosaurs then were set in the Triassic as well. On the synapsid side, the single hole in the skull, we had cynodonts, dogtooth, and you notice the two big fangs sticking down from the mouth of this Cygnothes, and that's characteristic of these cynodonts, and they will go on to produce the first mammals by the end of the Triassic. How do we know they were mammals as opposed to reptiles? Well, mammals have baby teeth. All the mammals, including us, have two sets of teeth, whereas reptiles just continually grow new teeth as needed. And so we get an animal like Brachyliodon, and it shows two sets of teeth. This very likely is an early mammal. This is another one, kind of rat-looking, small, characteristic of the mammals at the time. But it was the Pseudosutians that ruled. They were the kings of the mountain. As happens, the Earth starts to change. In this case, the megacontinent Pangaea starts to break apart, starts to rift apart. And where you get rifting, you get valleys and fissures in the crust, and these lead to volcanics and lots of volcanics. And so the Earth, once again, is impacted by large-scale volcanic eruption. But unlike the one that ended the Paleozoic, the one that killed everything off, the Great Dying, which was extremely warm, scientists are thinking that the one at the end of the Triassic may have been cold, and probably the fundamental difference between these is that the Great Dying, the one at the end of the Permian, was the volcanism was through a massive set of coal measures, which would have burned and produced a lot of carbon dioxide in the atmosphere, whereas that didn't happen with these rifting. And so we may have had more of a nuclear winter and a cold snap. And the dinosaurs, if you look at their distribution in the Triassic, they occupy the northern climates. They're cold climate critters. And so this dino fuzz that is increasingly thought to have covered these dinosaurs may have been a late Triassic lifesaver, as well as something else. A study was published May of this year, reported that the imaging of the thigh bones of 4 dinosaurs of different ages and different character, and a modern hummingbird indicated an abundance of molecules produced as waste during oxygen inhalation. And they say the molecules are a sure sign of high-powered metabolism, which warm-blooded animals use to keep their bodies warm. So thinking now is that the dinosaurs may well have also been warm-blooded. In any event, they survived, and the marine reptiles, the cynodonts, the flying reptiles, all survived into the Jurassic period from the Triassic, but the pseudoscians, actually, I think they survived, but they were substantially reduced. They were no longer the rulers of the world, and they were mostly crocodiles and crocodilians at that time. So this is basically the pattern then that happened. And what we went from this hot planet to a much cooler planet at the end of the Triassic. But we'll come back to that later, because I want to talk about the group that's missing. We haven't talked about the great marine reptiles that lived in the Mesozoic seas. Back in 1999, the BBC put on a series called Walking with Dinosaurs. Some of you might remember that. I thought it was absolutely fascinating, watched every episode. And I was struck in one of the episodes when a dinosaur came down to the water, and suddenly out of the water emerged a massive set of jaws that engulfed the poor little dinosaur. And I thought, what in the world is that? I've never seen or heard of anything of that size, which really surprises me, because something that big should have been part of the geologic literature that I would have encountered. And so that is why I call this next section, Don't Go Near the Water, because that could happen to you. Well, maybe. And I say maybe because I was really concerned as to how I missed such a monstrous beast, 25 meters long, 150 tons, according to Walking with Dinosaurs. But then I started checking on Liopleurodon fossils, and I found they were all, the biggest ones were 25 feet long. And it appears that someone in the BBC, as they were putting this together, saw 25 feet and automatically mentally translated it to 25 meters. And so in that way, Liopleurodon sort of tripled its size. And this carries on in later movies as well. In Jurassic World, a movie that came out just a few years ago, one of the scenes shows a crowd watching a giant mosasaur coming out of the water to engulf a really large shark. And that is a huge, huge monster. And indeed, the mosasaurs, as we'll see later, were real, honest-to-gosh monsters in the Cretaceous seas. And they were big, but not nearly as big as a Hollywood size. So that monster that came out of the water, in reality, would have looked more like this. But that doesn't have nearly the same impact as something coming out of the water looks like that. So we have a whole bunch of Mesozoic marine reptiles, big ones that rule the sea. And there are basically three groups: the ichthyosaurs, the plesiosaurs and their cousins, the pliosaurs, and the mosasaurs. We're going to start by looking at the ichthyosaurs. Ichthyosaur means fish lizard, and they're sort of halfway between in their appearance. Long beaks, lots of teeth, and they probably originated, may well have come from some of the aquatic diapsids that lived in the Permian. So the roots might go well back. There is a diapsid reptile, a shoreline reptile, that is thought as to be possibly ancestral to the ichthyosaurs. And so it is a possible ancestor as well. But basically, by the time we get into the Triassic, we're into things that start looking very much like ichthyosaurs in the water. And early Triassic, there were true ichthyosaurs. This is a skull that was collected by the now legendary Mary Anning. Mary Anning was a fossil collector. It was her business. In the 1800s, the cliffs of Dover, she dug out fossils and sold them. And she was probably responsible for the advances of paleontology in the 1800s as much as anyone, but she was never recognized for this because she was just a working woman. So she was not acknowledged until really the last century and this century, when people recognized that she really made tremendous contributions. And this is just the skull of an ichthyosaur. Look at the eye. This is the largest eye of any known vertebrate. It's still smaller than the eyes of the giant squid. And I wonder if this meant it was a night hunter or a really deep water predator. We don't know much about its habits. Last week, some of you may remember, if you stayed for the Q&A part of the session, I mentioned the Royal Tyrrell Museum in Alberta, Canada, as being one of the most spectacular paleontological museums on the continent. And they displayed a late Triassic ichthyosaur that was 21 meters long. That's huge. And there is an enigma associated with the ichthyosaurs. And that is, why did they disappear? They lived for 130 million years or something like that, and then they vanished. They were gone. What in the world happened? Well, there's some guesswork here on my part, but I note that their extinction, the last ichthyosaur, came just about during a temperature spike in the Cretaceous. The global temperature hit kind of a maximum for the time. And so the ocean was considerably warmer. And with that warmer water, the coccolithophores, tiny little plankton with calcium carbonate shells, really kind of took over. They were very, very abundant. And this would have impacted the food chain. And whether this is what happened or not, I'm not sure, but the Cretaceous food web may have looked something like this until this warm period and a major shift in the phytoplankton, which impacted the zooplankton and right on up the food chain, and essentially the ichthyosaurs starved to death. The second group of marine reptiles are the plesiosaurs and pliosaurs. And these are really very different in their appearance, but they are linked as basically the same organism with just a different set of jaws and a different length of neck. And they were large and they were predatory. They go back perhaps into the Triassic, where there were reptiles that may have been related to them. But the plesiosaurs persisted for a long time, right up to the end of the Cretaceous. So they had a long period in the water. And this is not an ancestral plesiosaur, even though it has many similarities. But this is that earlier pseudosuchian that we looked at before. And this is not a present day plesiosaur, even though it kind of in some ways wish that it were, but this Nessie is not a plesiosaur. The pliosaurs we've already met in Liopleurodon, and they are short-necked, big mouths with lots of teeth. And one of the questions is, why did they die out sort of like the ichthyosaurs, more or less the same period of time? And this is just one of the enigmas, but one of the thoughts is that as they were in a waning phase, the mosasaurs were coming on, and they're both very similar in their design. The mosasaurs are more efficient, and they may just have outfished the pliosaurs. The mosasaurs, we do know something of their origins. They come from land animals. They were big. This was the giant that came out of the water in Jurassic World. This is a very large one, had dozens of large teeth, good vision, probably warm-blooded, inhabited much of the Atlantic Ocean, and would have eaten anything it wanted to. And we have pretty good fix on the origin of the mosasaurs because they came in the late Cretaceous, mid to late Cretaceous, from coastal lizards that took to the sea. And so their ancestry is pretty well linked to the land in the early part of the late Cretaceous. And they really were major players out there. There are still relatives today, and some of them kind of nasty, like the Komodo dragon is considered to be a modern day relative of the mosasaurs. And they were big. But as we noted, their actual size was much smaller than depicted. So that's the story of the rulers of the sea at the end of the Mesozoic, the plesiosaurs and the mosasaurs. And they were not the only monsters in these Mesozoic seas. There were also marine crocodiles that were large in the warmer water, and even a pseudosuchian survived in the Cretaceous that, again, was in a warm climate area. And there were some big fish, some very big fish. And these are probably the biggest fish that have ever lived on the planet. So if you were on a Cretaceous shoreline and you heard the thundering footprints of an approaching Tyrannosaurus, would you go in the water to escape, or would you climb a tree? Well, I don't know about you, but I think I'd climb a tree. Which takes us to our next topic, T-Rex, velociraptors, and ducklings. Oh my. In the Triassic, it seems that we went from a very hot planet at the beginning to a chilly planet at the end. And then we enter a phase of the Earth's history that's really marked by climate stability. No other period of time that long exists in the history of the Earth and the Phanerozoic that doesn't have some major climate perturbations. And there were undoubtedly smaller perturbations than are shown here, but no really big ones. And as a consequence of that, there's about 134 million years in the Cretaceous and the Jurassic of relative evolutionary stability. And that's not to say that there weren't some differences. Stegosaurus from the early Jurassic is quite different from Triceratops from the latest Cretaceous. But other groups, like the sauropods, don't really change. These are the animals with the big bodies and long necks. and some of the largest land animals that have ever walked the planet. And the same is true for the theropods. They do increase in size toward the end of the Cretaceous, but basically the body plan remains pretty much unchanged over that entire period of time. And it's the theropods I want to focus on for the talk, in part because they're still with us today. And you don't have to look very far out the window to see them. The theropods were characterized by being bipedal. They walked on two legs, their hind legs. They had hollow bones and three-toed limbs, just like birds. And so Tyrannosaurus rex, Velociraptor, and ducklings are all theropods. The theropods have a family history that is fairly well put together. And the group I want to focus on here are the Maniraptor. And the Maniraptor, the name means hand snatcher. And that's not to be confused with other kinds of snatchers. But the Maniraptor have characteristically long, slender arms, fingers or claws, and feathers. And there are four groups: the dromaeosaurids, the oviparaptorosaurids, the archaeopterids, and the avians, the birds. We're going to look first at the archaeopterids. Back in 1854, there was a new popular exhibit in the city of London that displayed ancient life as it was perceived from the bones that had been found and put together by a few paleontologists and a few amateurs who reconstructed these strange animals, and they were considered to be big, brutish beasts that would lumber across the surface. And that was what was thought to have lived in these ancient times. So it was considerable interest when, just a few years later, a fossil was found in a limestone quarry in Germany with remarkably preserved feathers and wings. It was called Archaeopteryx, which means ancient feather wing, and the rocks that it occurred in were 155 million years old. And it was a strange fossil. It had feathers, long fingers, a jaw with teeth, a long tail with many vertebrae. Some of these features, like the toothed beak, the wing claws, and the long tail, are reptilian, but it also had a feathered wing, which is an avian characteristic. So what in the world was Archaeopteryx? It seemed to be something that was not quite a bird, nor was it quite a dinosaur. It's been called through time the first bird. But as it turns out, Archaeopteryx was not the first bird. In recent years, the dinosaurs of China and their remarkable fossil preservation have really changed the way we have perceived the whole dinosaur group. And the Chinese have found any number of fossils that contain feathers and show displays that look very much like birds. Auroras, 10 million years older than an Archaeopteryx and half a world away. And I would guess that the fact that we have these two similar fossils means that this kind of animal was actually pretty common. We just don't find the fossils of them very often. But when we do find the fossils, they are truly spectacular. So this was one of the early bird-like creatures that lived actually well before Archaeopteryx. There were others that lived a bit later. Confuciusornis, I pronounced it right, was a bird-like, probably reptile, maybe capable of flight. There were birds that looked like birds of today that were feathered dinosaurs, again found in China. And so the question is, where in this group of Maniraptorids did these birds evolve from? And the most obvious link that you would expect would be that they were derived from the Archaeopteryds, that they ultimately lost their teeth and became avians, modern birds. But there's a whole group of people, paleontologists, that think they would not come from the Archaeopteryds. The Archaeopteryds were a group that existed on their own, and the avians actually were derived from the dromaeosaurids, which is another of the groups of the Maniraptorid. And dromaeosaurids have some really interesting animals that lived in this particular group. There was Microraptor, which was probably a glider, but it had 4 wings, used its hind legs as wings. So it was small and sort of bird-like, but not it really, still pretty much a reptile. Then there's Velociraptor, and anybody who's seen the Jurassic Park or Jurassic World movies has known that Velociraptor is a large, scaly, nasty reptile or dinosaur, but in reality it's about the size of a turkey. And the actual dinosaur that was used as a model is Deinonychus. And Deinonychus is, I think, one of the most impressive of all the dinosaurs. It had feathers, its brain case was large, indicating it was highly intelligent. It was warm-blooded. It had 60 or more razor-sharp teeth. And there's some evidence, although not very good, that it hunted in packs. And this would have been an animal that would have been a terror on the late Cretaceous shorelines. And there were some big dromaeosaurids as well that I don't think I would care to meet on a dark night or even right out in the bright sun. So that's another possibility. But then there are the Oviparaptorosaurids as well, and they have some very bird-like members. Oviparaptoraurid means egg thief, and it took its name from the fact that one of the skeletons was found on top of a clutch of eggs, and it was thought that it was stealing those eggs, so it was given that name, egg thief. Later, they found that the eggs contained little Oviparaptorosaurids, and it was not breaking into the nest, it was actually likely protecting it. It was an egg brooder, just as birds do today. Some of the Oviparaptorosaurids were really kind of bird-like, feathered, they were flightless, and you compare one of them with a modern emu, and there's not that much difference between the two. So the connections within the Maniraptora remain really unclear, and we still don't know which pathway led to the modern birds. But somehow, somewhere within this group, they originated. Some of them were very much like ducks with teeth. And there were quite a few of them actually had teeth, fed on insects or predators. But then there were toothless birds as well, like the birds of today, that were seed eaters. They actually found a crop in this particular fossil. So the Cretaceous landscape, the Cretaceous forest, would probably have been full of birds or bird-like creatures flying about. And some of them would look very much like the birds of today, and some of them would look very, very different. So that was the way of the world 66 million years ago. A world that was about to change drastically because a very large rock, a chunk of space, at least 6 miles across, is headed in on a direct collision with planet Earth. Which takes us to the last segment today, which is a great explosion, then silence. This rock, this asteroid, would have impacted the Earth with an unimaginable splash or explosion. And where it came down was on the north side of what today is the Yucatan Peninsula in Mexico. And it left a crater that was 110 miles across and 12 miles deep. And that would have created giant waves that emanated out. Waves that would have been maybe 1,000 feet high, maybe several thousand feet high. In fact, a recent paper suggested they were a mile high. And waves of that kind would have absolutely devastated the lowlands and coastal areas around the continents. But it would not have had a particular impact on the central part of the continents. So while the waves would have wiped out an awful lot of dinosaurs, they could not have been responsible for the death of all of the dinosaurs. Our studies in the 1950s and early 60s on atomic explosions showed us some of the characters of a big explosion that we didn't know before, including an atmospheric shock wave that is capable of a real blast, and then a base surge, which is essentially a glowing cloud of debris that flows out away from that, from the explosion. And you can see those here in this photograph of one of the atomic tests back in 1951. The shock wave essentially starts kicking up dust as it moves across the land surface, and then the base surge comes along. So the shock waves from these atomic blasts just took everything down that was in front of them, and the base surge came along and essentially annihilated it. And the biggest explosion that we know of on this planet in historic times was the Krakatoa eruption, a very, very violent eruption in Indonesia in 1883. And it was way bigger than the 50 megaton atomic blast of 1961. And if we look at the energy released by Krakatoa, it was about 200 million tons of TNT. And if you compare that with the energy released at Chicxulub, which is equivalent to 100 trillion tons, the explosion of Krakatoa would be like a tiny firecracker compared to a blast of many blocks of dynamite, just not in the same ballpark. And an explosion that great, we just really don't know that much about what it would do. But we do have some evidence from the rocks as to what happened on that day, that the great impact occurred. And one of the lines of evidence comes from the sediment that accumulated at the time of that impact. You notice here there are a number of small, round, dark grains. See those? Quite a few of them in there. And those are microtectites. Microtectites are essentially fused rock. They're droplets of rock that had been molten or even in a plasma state and then fused. And they occur all over the world. You find these everywhere. So this was a worldwide phenomenon. So while the impact was in the Gulf of Mexico, this was a way of impacting the entire globe. And they occur in beds like this. They all came down sort of in one mass. It may have taken a while, it might not have been one clump, but they did come down pretty much all at the same time. So how in the world did they get there? Well, you have this rock coming in to the Earth. It's about the size of Mount Everest, maybe a little bit bigger, and it's moving at a speed of 45,000 miles an hour is the estimate. And as it comes in, if it's like a bullet fired underwater, it creates a vacuum behind it. And if you were standing in the right spot, you might have been able to look up through that vacuum and seen the stars. And it would have been the last thing you would have seen, because within instants, you would have been vaporized along with a vast amount of rock material. And that rock vapor shot back through the vacuum into space, where it spread out and in short order encompassed the entire Earth. How could it spread so widely so quickly? Well, here we have some evidence from the Tonga eruption just this year. And NASA measured winds in the upper atmosphere, in the ionosphere, that were 450 miles an hour. Very, very strong winds in the upper reaches of the atmosphere. And this explosion was trivial compared to the impact of Chicxulub. And so we don't know what the upper atmospheric winds would have been, but they would have been phenomenal and are capable of spreading this debris all around the Earth, where as it cooled, it starts to fall back in again. And as it falls, these little grains that are essentially liquid or plasma to begin with lose heat and become pebbles or become rock. And that heat transfer goes into the atmosphere. And there are estimates that the Earth's atmosphere might have been 1,200 degrees Fahrenheit for a fair amount of time, maybe 12 hours or so. And there's nothing on the surface of the planet that could survive that. So we look at the survivors. We've got the mammals, the avian dinosaurs, the birds, snakes, lizards, crocodiles, and turtles. The dinosaurs, the flying reptiles, the marine reptiles are all gone. And one way you could protect yourself from that heat was being underground. It's been estimated that 3 inches of soil might have been enough to protect anything from that vast heat on the surface. Well, mammals live underground, and today so do a fair number of birds. Crocodiles and turtles certainly don't live underground, but they make nests that they bury their eggs in some inches of soil, or in the case of sea turtles, sand. And so the eggs may have survived even though the adults were wiped out. And the marine reptiles, well, fish could have moved down into deeper water and stayed there when the surface waters came to possibly near boiling temperatures. But the marine reptiles had to breathe. They had to go up to the surface to breathe. And that may have been their downfall. So the result is a vast silence on a barren world in the aftermath of this huge impact. But birds would sing again. The earth would once again become green, and a group of animals appear, some of them very strange, would occupy the earth, including an unimposing primate whose descendants would go on to make things like this. So next week, we'll take this on, life and death in the Cenozoic era. And that takes us through the Mesozoic.